Hello, we'll learn about one more property of the conductor. So if I'm having a conductor and if we provide the external charge, extra charge to the conductor. So if I'm going to provide the extra charge, and let's say because of that extra charge, the charge density onto the conductor is sigma. Okay, sigma is the charge density onto the conductor. Now I'm not claiming that sigma should be constant. Obviously it is a conductor and the charges, when I place the charges here, it might go anywhere actually. So there might be, the sigma might be variable. But I'm only concerned about the sigma, let's say in a small region. So if I'm taking a very small region, now in that small region, I can assume that sigma remain constant or the variation is not that large. Okay, so let's enlarge this small segment. So if I'm going to enlarge this small segment, this is that small segment, and there is this positive charge, and the sigma is the density, and since I'm assuming it's a very small area, portion, so sigma remain constant. Okay. Now, if due to this segment, due to this conductor, if I want to calculate the electric field very nearby to the surface, very nearby, I'm going very nearby. So if I'm going very nearby, this small segment will act as an infinite plate, because you see, right now if you see a pen, this is a pen, and the length of the pen you can see, but as you approach towards the pen, and when you go very nearby, and from that reason, if you start looking at the pen, this pen will look like it's of infinite length. Okay. The building, same case with the building. When you see the building from far away distances, they look very small, but when you go nearby to them, they look very big. So when we are approaching this small portion, this small portion will look like as if it's an infinite plate. So if at this small portion, if I want to calculate the electric field, one thing is sure, it's a conductor. And the electric field to conductor is always perpendicular to the surface. So electric field at this point will be equals to sigma upon epsilon naught. Meaning we can use the same formula as we used to use in case of thick plates. Okay. So this will be the electric field. So if I'm having a conductor, if I calculate the electric field very nearby to the conductor, very nearby to that conductor will be sigma upon epsilon naught. That is also a property. Now, to actually calculate the electric field, all you have to do, calculate somehow that value of sigma. Because you see, this will be a difficult task because the sigma keeps changing. The moment you change something external, the sigma will again change because the charge can redistribute at any point of time. Okay, but the field very nearby to the conducting bodies will be sigma upon epsilon naught. That formula one should memorize. Okay, we'll be using this formula very frequently in the questions. Okay. Thank you.